Hello, this is Mrs. Kincaid and I want to welcome you to your very first Algebra 2 video. We're going to be taking a look at some vocabulary as well as some solving equations today. So you're going to need some notes and a calculator later on. Remember to take those notes in that notebook that we established, and feel free to pause this video if you find that I'm going too fast. First, we're going to start with the properties of real numbers. These are properties that you saw in that pretest. Properties of real numbers are ones that you've learned in Algebra 1, but it's been a while, so it's always good to review those. These are the properties we often use when we're solving equations, or we often understand but maybe don't often put into words. So we'll start with the associative property. Basically, this changes the way the numbers associate or are grouped. Now there's two ways to think about this property. There's the associative property of addition. And when you look at the associative property of addition, you basically can change the way the numbers are associated or are grouped together. A lot of times in math, to group, we use parentheses. So I'm going to use numbers here. This is like saying that 3 plus 4 plus 5, if you were to group the 3 plus the 4 on this side, and you took those same numbers, 3 plus 4 plus 5, and group the 4 and the 5 on this side, basically that property says this value is the same. That 3 plus 4, if you add those first, and then add the 5, you'll get the same value if you add the 4 plus the 5, and then add the 3 later. It changes the way the numbers are grouped. In one side, the 3 and the 4 are grouped together. On the other side, the 4 and the 5 are grouped together. There's also an associative property of multiplication. This is the same idea, except instead of plus signs, we're talking about multiplication, so you'll have times symbols here. Little dots. 3 times 4 times 5, and then 3 times 4 times 5. Again, notice how the parentheses are changing who's grouped together. That's the associative property. The second property we want to look at is the commutative property. This changes the order the numbers are written in. So again, for addition, and then we'll look at one for multiplication. This time I'm going to use variables instead of numbers. It's the same idea. This is saying that when you add two numbers, if you take a plus b, you get the same value as if you take b plus a. That makes sense. 2 plus 3 is the same thing as 3 plus 2. We just kind of know that, but it's the commutative property that says it's true all the time for anything being added. Multiplication, the same idea. A times b is the same thing as b times a. The commutative property changes the order that those things are written in on either side of the equal sign. The identity property. This maintains the identity of a number or keeps it identical. This is the way I like to remember it, is maintaining a number's identity. So if we, again, think about addition and think about multiplication, with addition, if I have a number and I want to maintain its identity, I add 0 to it. 3 plus 0 remains 3. The identity property looks like this. Any number plus 0 will stay that any number. Multiplication property is a similar thing. Any number times 1 will remain that number. Now let's look at the inverse property. The inverse property uses the inverse. So I always like to think about inverse operations. It's like when we see a number and we want to do the opposite of it when we're solving an equation. We want to, cancel it out or get rid of it. We think about that when we talk about addition again and multiplication. What does that look like in terms of the inverse property of those two? The inverse property of addition would be a number plus its inverse, or in this case, the negative number, will make 0. Okay? So essentially, a number plus its negative will cancel each other out and make a 0 value. Multiplication, think about a number times its reciprocal, will make 1 when you multiply. Notice that 0 and 1 are in the inverse property and they're also in the identity property. They're just in a different location. And the fifth property is the distributive property. This is the one that most people can identify right away. This looks like 3 maybe, and you have some parentheses. A plus b. In algebra, we would distribute 3a plus 3b. We multiply a number by whatever's in those parentheses, or a value by whatever's in those parentheses. So you multiply or distribute to several terms. Okay, other vocabulary notes. A lot of times in directions you're going to see words like expression, equation, simplify, evaluate, and sometimes people aren't sure exactly what those are talking about. So let's be clear, an expression is an algebraic statement that contains variables and numbers. So 3a plus 12 would be an example of an expression. Notice that it does not contain an equal sign or an inequality symbol. Notice in there there's no equals 14. It's just terms. There's not an equal sign there. Whereas on the other hand, an equation is also an algebraic statement, so it has variables and numbers, but this time it equates two quantities. So it does have an equal sign, and then I can solve it to find a solution. So it might look at like 3a plus 12 equals 10. Okay, something like that. Notice that there's an equal sign in there, and I could then solve it because it's an equation. Okay, I could solve it to find out what a in fact equals. An inequality is also something we're going to be looking at quite a bit. An inequality is another algebraic statement that compares two quantities, but it uses descriptions like less than, greater than. So it contains an inequality symbol. So it might be 3a plus 12 is less than 10. Okay, that's an inequality. Again, we can solve that because it has that divider, that inequality symbol, like that equal sign, divides two sides that we can work with. And lastly, for vocabulary, we need to talk about the real number system. This year, we're going to open up a whole new world into a different number system called the imaginary number system. But there is something called the real number system. Many times you see mentions of this in directions, like round to the nearest integer or whole number. Many times people aren't sure exactly what we're asking you to do. Because numbers are categorized in different groups, so the real number system can best be illustrated in this chart. Take a minute and write this chart down in your notes. This is the way the real numbers are broken down. Okay, we have different groups within here. I see this big group right here called the rational numbers, and then there's a big group over here called the irrational numbers. The difference between those two is that rational numbers can be written as fractions. If you think about the word ratio inside there, that's what that means. So these are possible fractions, or can be written as fractions. See in here repeating decimals, those can be written as fractions. Whereas on the other side, irrational numbers are numbers that cannot be written in fraction form, like pi. Pi is an irrational number that goes on and on forever. It doesn't have any pattern to its repeating decimals or decimals within there, so it doesn't have any repeating or pattern decimals, therefore it makes it irrational. Same thing with some square roots. Rational, irrational numbers, those two we see quite a bit. On the rational side, on the side of numbers that can be written as fractions, you have a subset of that, or a smaller group of special numbers called the integers. Take a look at the integers. These are numbers that you would put on the number line. So they include negative values, 0, and positive values here. Okay, those are your integer numbers. Within that group, if we forget about the negatives or we throw out the negative values, we create another set of numbers called whole numbers, like 0, 1, 2, 3, 4, 5, 6. Okay, those are whole numbers. A lot of times integers and whole numbers get mixed up. And then within the whole number group, let's throw out the number 0, and then that creates a group called the natural numbers. These are the numbers that we start counting with as kids. Usually your parents start by showing you 1, 2, 3, 4, 5, 6. Most of the time we don't talk about 0 right away with kids. Okay, those are the natural numbers, the numbers that you can see as small children, okay? So this is how our real number system is broken apart. Like I said before, there are different types of numbers called imaginary numbers that we're going to learn about later. That would be the other side of this chart, where we are not just talking about real numbers, but all numbers in the world. Okay, now we're going to take a look at what do we do with all this knowledge? Okay, what do we do with all this vocabulary? What do we do with all these properties? We use it to solve. So we're going to find the solution to equations. Okay, find the value that makes the statement true. You spent quite a bit of your time in Algebra 1 solving. We're going to solve equations right now. Let's write just two examples here. This is the first one. We're going to solve this equation to find out what x equals. Okay, I see on this side of the equal sign, I see some distributive property actually on both sides. So I'm going to go ahead and do that first. 3 times x is 3x, 3 times 4 is 12. And then on the other side, negative 2x. Negative 2 times negative 5 makes positive 10. Now I'm noticing I have x on both sides of the equal sign. I'd like to get them together on one side, so I'm going to add 2x to this side and also add it to the other side. That makes 5x plus 12 equals 10. Okay, continuing to solve. My x's are together now. Now I'm going to subtract 12. I have 5x equals negative 2. And then last but not least, I'm going to divide by 5. So my answer is x equals negative 2/5. In Algebra 2, quite often we're going to leave our answers in fraction form. Okay, so do not feel that you have to write that as a decimal answer. Here's our second example. Again, I see the distributive property here. I see 2 times x and 2 times negative 3. So what this side becomes is that 3x plus 2 more x's, and then 2 times negative 3, negative 6, 24. And now when I look, I see that I have x's, but they're on the same side of the equal sign. They're both over here. Here's my equal sign. I just combine those because they're like terms. This makes 5x minus 6 equals 24. Now I can go ahead and solve this. Add the 6, 30. 5x equals 30. Therefore, x, when I divide by the 5, becomes 6. Okay, so we have talked about some vocabulary. We have also talked about solving equations. Those are two key things that you're going to need for Algebra 2.